Okay. Okay, so as I was saying, today's presenter is going to be Alessio Stalla, and the presentation will be about bridging the gap between textual and projectional, a proof of concept. Alessio is a language engineer at Strumenta and is mainly working on textual or projectional editors and IDEs and statical analysis tools and model-to-model transformations. In his free time, let's say, he's also writing on the Strumenta blog, and he's been working as a lead developer on the open source project Portofino, a web application framework. He's also contributed to ABCL, which is a common Lisp implementation on the JVM, and a bit on the Groovy language. He's actively participating in the Java local community and the international community, and is in the past he worked on with many different web technologies around the Java environment. So thank you again for participating. I will just leave to talk to Alessio, and if you have questions, feel free to ask them during the talk or at the end of the presentation, as you prefer.
Okay, thanks, Lorenzo. No. Okay, we should have rehearsed. I cannot share my screen, so I think somebody has to enable that.
I think Lorenzo has to do that.
Okay.
Okay, now it's working. Okay, can you all see my screen? Okay, yes. So as Lorenzo was saying, this presentation I chose to title it Bridging the Gap Between Textual and Projectional, and this is about a proof of concept. So we'll see a demo of some of the work we've done at Strumenta. We've already presented this at the LangDev conference a few weeks ago. So this is the same presentation, but we've took the time to rehearse it. And so where I am, Lorenzo already said, so we can skip the part. So my plan is to go over textual and projectional editors, what they are, and do a quick recap. Nothing too deep, because we probably will all know what we're talking about, but just to set the boundaries, the map the terrain we're moving in, and then I'll present some ideas to bridge the gap between the two, and I'll show a demo, and we'll have a Q&A session in the end, but feel free to interrupt me even during the presentation to ask questions. So we're comparing textual and projectional editors. So let's quickly define what a text editor is. By text editor, I mean a library or application that presents code or some kind of model, could be configuration, could be any other kind of model, and it both stores the code / model and presents it as text, so as a sequence of characters. Now, visually, that may probably be, it will be presented as a sequence of lines, so not a really a flat sequence of characters, but still the idea is that the model is represented and interacted with as text, as plain text. So this is a family of technologies that we're very familiar with, both as users of this kind of editors and also as developers of these kind of editors. So we have mature libraries for building them. We have mature applications that we can extend. We have well-known library algorithms and vast literature on how to write a text editor and how to write a text editor for code specifically. And we all know that this model is very versatile, but also has some limitations. So in particular, where the expressiveness of the code or the model that we can write in such an editor is limited by the need to adhere to a textual syntax that also can be parsed and understood by a machine. So we know we can represent a lot of different notations as text, but still sometimes they're a bit forced, and sometimes it's really impossible to map some notation as practical text. But on the other hand, the text is free form, so the editor can be really simple and can be extended progressively with more and more language intelligence. That would be based on a parser, so on a component that is able to reconstruct the structure of the model from the text. And again, this is a very proven, mature technology, but with its limitations. In particular, even the best parser will sometimes break on malformed code, and when writing in an editor, the code is almost constantly malformed because you're typing it character by character, and yeah, even if in the end you type a perfectly good structure in the interim, it will be broken. So even the best IDEs, the best language plugins, from time to time they get confused. And also a textual editor can be a bit hard for novices to approach because it's so free form, it gives no guidance. You get a blank page and you have to type something and you don't know what. So that's of course mitigated by a lot of tools and libraries that do scaffolding that automatically generate a project from some description, but still we have limited room for guiding novices and in general for interactivity. On the other end of the spectrum, we have projectional editors, and these I define as editors that store the model or code as structured data and also present it as a structured interface. So they allow the user to not just work on individual characters, but to work on the structure of the model. And that may also not be textual at all. That may be a graphical representation, for example. And these kind of editors, even if they've been existing for quite a long time and there's literature on them, they're still quite unfamiliar for many users, and they need a learning curve that could be more or less steep. And it's also unfamiliar for us developers that want to build such editors. And the libraries and tools that we have at our disposal are still somewhat less mature than what we have for textual editors, and often for several of these kind of editors, particularly MPS, maybe the reference implementation of a of a projectional editor, the text editing experience out of the box is not that great. They require quite a lot of development work to bring the experience somewhat on par to a text editor that works out of the box. But on the other hand, we get, with a projectional editor, we get much more possibilities for expressing constructs, because we're not limited by the need to adhere to some textual syntax. So we can embed, for example, diagrams or tables or images or other kinds of representations, projections. And so they offer some attractiveness to us. They free us from some of the limitations of textual editors, and they also free us from parsing. So the problem of having to work on a broken model because the user is editing is vastly mitigated up to a certain degree, because parsing is, like email, is something that likes to creep back in any kind of software endeavor that one builds, because yeah, there will be maybe micro expressions or small pieces of text that is still easier to parse rather than to model as a projectional structure, but mostly in a projectional editor we're free from parsing. And we can also, as part of the offering of a more interactive experience, more varied interaction, we can also offer more guidance to novices. So we can, for example, have the editor start with some pre-populated nodes and maybe offer a simplified view that you can then toggle to the expert mode when you are confident enough. So they offer a greater learnability in a sense.
Can I make a quick observation?
Yeah.
The first 2 points, unfamiliar need, learning curve, and poor text editing experience out of the box. I think this is mainly a problem because the people who end up doing the coding are coders. So if someone's first experience is a projectional editor, or if someone is trying to solve a problem prior to, without having a programming experience using a projectional editor, I don't think that they have that same experience. It's just because we as people with decades of experience are so used to typing really fast and having things work in the way that we expect them, that when something works differently, we get thrown. But it'd be a very interesting experience if children or people that were new to programming, their first experience was with a projectional versus, which often it is with things like not Sketch, the learning programs are often projectional anyway. But yeah, it'd be interesting to see whether these two remain when you're not talking about people with lots of experience.
Yeah, I agree. That's also an expectation that we have, and yeah, that I agree. Anyway, let's move forward. So the topic of this talk is, can we somehow find a middle ground between the two? Can we find a solution that has all the pros and none of the cons? Well, that's impossible, but still, can we bring something from projectional editors together with something from text editors and obtain something that is better than the alternatives? So targets that I set. Sorry, there's a noise here. Give me a moment.
Was just done to prove that this is live. This is not pre-recorded.
Okay, sorry for the interruption. So can we get something that is more expressive than plain text, so that allows us to insert other kinds of notations that are not easy to represent as text, that gives a good editing experience out of the blocks, so that you can just start typing without learning too much, that is based on mature libraries and tools, and that is ready for deployment on the web. Well, maybe we can. And one idea that we had was to take a word processor and improve it in a way. So that may sound strange. So because we know a word processor is something that we use to write maybe documentation, not code. So it's one of the things that as computer users, we learn early on that you write some stuff in Word and some other stuff in Notepad, and they're not the same thing. So this may look strange to you, but well, crucially, word processors are already a sort of projectional editors, in that even though it appears that you're writing plain text, you're actually, when you use Word or Google Docs, you're actually editing a rich document model that is both stored as structured data and also somewhat presented as structured data. This model will consist of paragraphs and tables and images and lists and whatever. And the operations that we can do on such a model are not limited to text. For example, we can, I don't know, indent a whole paragraphs or change the bullet style of some list. So yeah, it's a sort of a domain-specific limited projectional editor. Now, of course, the limitation of a word processor is that the meta model or the schema of the document is fixed. It's only meant to edit textual documents. Potentially, it may have limited extension points. For example, maybe in Word, you can enter mathematical formulas or other external controls, but usually from the point of view of the editors, these are just black boxes. They're images. Then you, I don't know, you insert a formula from the point of view of Word, it's an image, then you double click on it and then another window opens and you can edit the formula with the dedicated interface, but it's not really integrated in the same editor. So, but luckily we have some tools that help us in that regard. In particular, the ProseMirror project, which is a word processor toolkit. So it's not a pre-built editor component. It's a set of components that work together, that you can combine together to build a web-based word processor like Google Docs, for example. And crucially, ProseMirror has a free schema, so it's it doesn't come with a fixed meta model of how documents are to be represented. We can define our own or we can also extend some built-in default schema with new blocks, for example. And so that allows us to combine standard rich text blocks with other kind of structured blocks that are integrated. It's not like in Word where you get a sort of an image that you have to use another editor to interact with. You can define new boxes and you can define how they interact with the rest of the editor. And we can also incorporate some parsing inside these boxes, and as we'll show. So why choosing this this solution? I hope the demo will somewhat convince you, but just to do a quick recap, ProseMirror comes with good text editing, with a good text editing experience out of the box, because it's made for that. It comes with hooks for copy and paste and keyboard shortcuts and all kinds of extension points and interaction points that you may want in an editor, in an advanced editor. It's transactional, so it's well suited for collaborative editing, for example. And that's in the core. It's out of the box. It's already integrated in many frameworks, libraries, products, and so it's easy to, for example, build a rich UI around it with existing libraries. It has an very active community, and it's open source and it's modular by design, so it's very easy to extend, even if the API is not the simplest in the world, but it's very well documented, and you can ask for help in the community. So that's a nice experience from my point of view. So now we'll do some little demo. Keep in mind that this is only a proof of concept. It's the results of some internal research work at Strumenta. It's not open source technology. Maybe in the future it will be, I don't know, but it's not now. But anyway, this is not just let's play around. It's something that is derived from a real world case study that we did for a customer. So enjoy the demo. Sorry. How do I go out of this? Okay. Okay, here you can see an instance of the editor, and it may probably look underwhelming if you expect a word processor like Google Docs, because you only see very few controls here, but this is on purpose. The ProseMirror toolkit only deals with the contents of the editor, and it's up to the developer to build the UI around it, the menus, the toolbar, and so on. And so for this demo, we only built a very limited editor experience, just to show that this is text that we can edit, and we can add styles, for example. And we also chose to using CSS to show this rich text areas with this color, which is not the usual black and white, and to distinguish them from code sections that we'll insert. later. And we can already see that even though here we're editing text, what's really happening is that we have a structured model that we're showing here as a JSON object that represents this this document. So even though it looks like it's a textual plain text editor with some markup, it's really a rich model. Now let's see some of the magic that we've added. So here, where the cursor is placed, we have a special block that is of type parsed text block. This is a kind of block that we defined. So the text we write here is passed through a parser, and in particular, we chose to use a Kotlin, a parser for the Kotlin language, using an open source library. Sorry, an open source grammar. The parser is implemented with Antler 4. So here we can write Kotlin code, and we can see that we've hooked some logic into the parser. So, as for example, to report parsing errors here. Now, of course, this is not a full code editor. It's really simplified, but it's the idea is to show already that we can mix rich text with something that is already a little more structured and that we run through a parser. And we can see that in the model, we can actually insert the structure of the parsed code. Here, it's trivially inserted as a string because the Antler 4 generated parse trees are not serializable as JSON, so they wouldn't fit on an HTML page. So we flattened the structure and printed it as a string, but here any kind of JSON object would go here. And so we could have made something more structured out of the results of the parser. Still here, we're writing free-form text that is then parsed as Kotlin. But what we could do is to add an even more specialized block. Now here I pressed Control Space to ask for code completion, and the menu offers me the possibility to add a class block. And this class block is again a custom block that we defined that is somewhat projectional. We can see that we have some fixed parts that we cannot edit. We cannot.
Sorry, Alessio.
Yes.
There is people asking if you could increase the font size.
The font, yeah, sure. Is this okay?
I think so. Yes.
Okay.
Thanks.
So this is a kind of projectional block that has some fixed parts that are keywords and punctuation, and some variable parts that we can write. So, for example, this class has a name field that we can fill. And we can see that this block is, we know its kind, it has some structure, and it has, in particular, it has a field whose content is the some class text that we just typed. And inside the body of this projectional block, we can write some other free-form code, Kotlin code. But in this case, this will be limited to code that can go in the body of a class. So for example, if I write import, this is not legal here because you cannot write import inside some class. So even if but for example, we can define methods. So even if we are still using parser, we're limiting the scope of the text to be parsed. We don't have to deal with the whole file anymore, but for example, just with the contents of a class. And we can apply this we can apply this pattern recursively. So here, for example, we can add a method, another kind of block that we defined. And so again, this is a projectional block that has some fixed parts, it has some fields, and then it has a body, which is a free-form code block where we can write Kotlin code. And again, in this case, this will be limited to the kind of code that we can write inside inside the method. Sorry, I accidentally deleted. I don't know, some object. So you can see here that we can mix and match projectional blocks with more traditional code, text-based code editing, and we can also insert rich text. So, for example, documentation. This is some documentation, for example. And apart from defining the projectional blocks, we didn't have to do a lot of work on ProseMirror to get this, because, for example, node selection is something that is already built in. So, for example, by hitting meta click, for example, I can select a whole node, for example, and this is built in ProseMirror already. And we can add new behaviors. For example, if I try to delete this open brace, it will do like in MPS, for example, it won't allow me to delete this piece of text, and will instead select the whole node. So if I press backspace again, for example, the whole node is deleted. I also have undo and redo out of the box, for example. I have selection out of the box, and also copy and paste as text. So here I can paste this as text. Then if you want, you can hook into copy and paste to know that, for example, if I select this part, I'm copying a whole node. So that is something that you have to customize to provide your own code to do. But
sorry. Oh,
yes.
Sorry. I just wanted to say that Mike and Paul might have some questions. They raised their hands.
Okay, sure.
Okay, so the question I had, that you've got two functions here, one that you just typed in and one that you use the code completion to add a structural block to for your projectional editor. Are there plans to recognize like the first function that, oh, that should be rendered the same, should actually introduce some new structure into it instead of just being considered part of a parse source tree, because there's like an inconsistency there, right?
Yeah, you can this is not something that we implemented yet because it's just a proof of concept, but in ProseMirror you can say that whenever the user types something, for example fun, you replace the text that they just typed with a block that you decide how to create. So we could do for like NPS does, for example, that when you write, I don't know, 2 + 3, it will let you write it as text, but it will then recognize that you've written plus, and so it will create a plus node with 2 and 3 as
I'm
children.
I'm following.
Yeah.
Appreciate it. Thank you.
And there's Paul also, I think.
Yeah, so I was just trying to find my mute button. Yeah, so with regards to how this is stored, you have your classes and your functions that are part of your projectional side. That's obviously in a sort of AST. But the bits that are free typed, are they stored? Are they also converted into an AST, but then you won't be able to edit them in the same way, or are they stored as a string within the AST, which is part of your not a string, but your antler pass string in the structure? So you have AST code that's being passed, AST code that's being passed, or
so what we did is in blocks that have some parser attached, we defined a bunch of attributes. So in this meta model that you define, you can say which kind of blocks you have, so roughly which classes and which attributes they have. So a parse text block has a rule that we insert. Right now we insert it programmatically when we create a block, and you cannot change it. So it says what kind of code can go there. So it's the entry point into the parser. And then it has a parsed field that will contain the result of the parsing. Now here, since we wanted to show this as JSON, we couldn't put the antler parse tree as it is here because it contains circular references. So as a quick fix, we serialized it to a string. But yeah, the next maybe
I guess my important question is because one of the huge advantages of the projectional thing is you're immediately editing the AST. And here does your I mean, eventually, will your AST of the projectional part recognize references in the parse bit? So if you have a variable in one place, is it recognized and automatically changed? So let's say I change it in later on, then can it be changed back in the parse bit?
Yeah, the idea is that this document model is very close to the content of the editor. So it's not an AST, it's more of a concrete syntax tree because it contains some sorts of things that are used for presentation, for example. So if we were to evolve this into a little more mature projectional editor, for sure we would have a step that converts this document model into a more synthesized AST that may merge things or combine information from different sources and vice versa to return from the AST to this model, because as it is, this is very tied to the editor structure, which makes sense for the editor, but it's not the kind of structure that you want to work on when you're working on the model. So to do transformations, for example, to do code generation, to do analysis, whatever, this is, you wouldn't, this model is not efficient. It's not the right representation. So this would be the first step into a chain of transformations, for sure. I don't know if that answers your question, but
yeah, the thing that's driving at the back of my head is that I know in the predecessors for projectional editing was from the 70s and 80s, but were these sort of, I forget what the term was, but like context-driven programming, and you had and eventually they would face the same problem that it was always easier to parse the text than to use it, but then they'd always end up parsing at the leaves. So right down at the end of the AST, they'd be parsing little parts of the code, and that just never seemed to scale. So that's what I'm wondering when you're mixing the parsing and the structured editing. That's correct. When you're mixing the parsing and the projectional, I wonder if that's if that's two worlds that cannot cross. But that's I guess for you guys to find out.
yeah, that's still very very proof of concept. We don't know where this will go. So the eventual idea is the stuff that I wanted to show is the projectional or structured part. Now, this idea of mixing a parser into the picture is to hint at maybe some transition path that you can maybe start from a textual language and then gradually bring it into the projectional world. But maybe this doesn't work. Maybe the solution is just to start from a projectional approach from the beginning and forget this migration on, or only, as you said, only apply parsing at the leaves of the tree and not intermix the two. Yeah.
Thank you. By the way, it looks great.
Thanks. Any other questions?
Maybe I could stop the recording, so if there's any people feeling shy, they can ask the questions. So I will stop the recording in the meantime. And thank you, Alessio, for the presentation and the interesting demo.
Thanks.